Hello students, we are going to take up the chemical properties of sulfuric acid. Sulfuric acid, children, is a dibasic acid. Dibasic acid means it forms two series of salt, hydrogen sulfate and sulfate. That means it has got two hydrogen ions. It replaces one by one. So when it is hydrogen sulfate, that salt formed is known as acidic salt. Okay, now we are going to study this. So first is when we take dilute sulfuric acid, right, and we want to know whether it is acid or not, what we need to do is we need to add the indicators. So if we add blue litmus paper will turn red, methyl orange solution will turn pink, and the alkaline phenolphthalein solution, which is pink in color, will change to colorless. So these are the indicators which are going to confirm that the compound you have taken is acidic in nature. Now, how will you confirm that it is acidic in nature? Chemically. Then in that case we add chemicals. Okay, so to know, first we have active metals. So if we take active metals like sodium, potassium, calcium, magnesium, aluminium, iron, zinc, right? So when we take metals and we pour them in sulfuric acid, dilute, what will happen? These metals are lying above hydrogen, so they immediately substitute or replace hydrogen. So what will you get? Hydrogen, and you will get metal sulfate. So if you have taken metal and you drop it in sulfuric acid, you will get metal sulfate and hydrogen gas will be liberated. Is this clear? Right? Now, remember, if you are taking potassium, sodium or calcium, now these are very active metals. So if you add sulfuric acid, the reaction may be explosive in nature. So we avoid using reactions, sulfuric acid with potassium, sodium or calcium. So we prefer taking little mild metals like magnesium, iron, zinc. So when this time you visit chemistry lab with your teacher, okay, request your teacher to show you the experiment, right? So when you drop magnesium metal or iron nails, you will find the bubbles of hydrogen gas coming out. So magnesium, when dropped in sulfuric acid, dilute, hydrogen will be released and you will get magnesium sulfate. Likewise, if you drop iron in dilute sulfuric acid, hydrogen gas will be released and you will get ferrous sulfate. Is this clear? Now, if you do not take metal, you can take metal oxide. So if you take metal oxide, what will you get? Metal oxide, the oxide of metal and hydrogen of sulfuric acid will form what? Water, and you will get metal sulfate. Okay? So let's see, when we take potassium, magnesium, zinc, copper, these oxides, so the oxides will combine with hydrogen to form water and you will get metal sulfate. So potassium and sulfate, you will get potassium sulfate and water, or magnesium sulfate, water, or you can take zinc sulfate, water, or copper sulfate and water. Now instead of oxide, if you take hydroxide, now children, hydroxide is a base. Okay, so what are bases? Bases are the ones which absorb, which combines with acid to form salt and water. Now the bases which are soluble in water are known as alkalis. Okay, so water soluble bases like potassium hydroxide and sodium hydroxide are known as alkalis, and the reaction is known as neutralization reaction. What is the product? The product is salt and water. Now when you take sulfuric acid, it is a dibasic acid. Remember children, so it forms two series of salt, sulfate salt and hydrogen sulfate salt. So you will get sulfate and hydrogen sulfate salt. Okay, let's see. Okay, so when we combine sulfuric acid with any hydroxide, you are going to get sulfate or hydrogen sulfate. Now for this there is a rule. Remember, if you take alkali is always going to form two series of salt, sulfate as well as bisulfate. But if you take a normal base which is not soluble in water, like you take magnesium hydroxide, ferrous hydroxide, copper hydroxide or zinc hydroxide, then they are going to form just one series of salt, and that series will be sulfate series. Is this clear? Okay, now how it happens, because if you take sulfuric acid, you can see, if you take sulfuric acid, the sulfuric acid, it is going to break. Okay, so it breaks. First it forms one hydrogen ion and the second hydrogen sulfate ion. Then this hydrogen sulfate ion further breaks into sulfate anion and another hydrogen ion. So you get two negative anions, sulfate and hydrogen sulfate, hence you get two series of salts. Okay, and this you will get with the alkali. So if you take example of potassium hydroxide, right, so one molecule of potassium hydroxide with one molecule of sulfuric acid will form potassium hydrogen sulfate, and when you take two molecules of potassium hydroxide, you will get potassium sulfate. Is this clear? You need to practice these reactions well, children, right? Now another very important thing is that if you take the alkali amount in little, you get hydrogen sulfate salt, and when you take alkali amount in excess, you always get the sulfate salts. Okay, so this is what we discussed over here. That is, when you have got one part and one part, you get hydrogen sulfate. When you have taken more of alkali, you get sulfate salt, right? Now we take what happens when carbonate combines with sulfuric acid. So whenever we take carbonate salt, what happens? This carbonate salt has got what? Carbonate, CO3 2 minus. So carbonate means it has got one carbon and three oxygen. So out of this is what? Carbon dioxide. So it releases carbon dioxide and this oxygen is left. So this oxygen combines with the hydrogen of sulfuric acid and forms water. So let's see the reaction. Okay, let me just erase this so that this becomes little clear. Okay, right, now it is clear. So potassium carbonate when combines with sulfuric acid, so hydrogen and carbonate, they will combine to form water and carbon dioxide, and you will get potassium sulfate. Similarly, you will get sodium sulfate, water and carbon dioxide. Then again water and carbon dioxide, and you will get calcium sulfate. This way you will get zinc sulfate and copper sulfate. So as we move down, what will happen? The formation of the sulfates will take place along with water and carbon dioxide, but of course the speed of reaction will get slowed down. Okay, now you will find if we take calcium carbonate or lead carbonate, then after some time the reaction stops. Now the reason is why the reaction stops. So what is actually happening, children? I'll explain. See what happens when you take calcium carbonate or lead carbonate. So say this is the calcium carbonate, right? And when it combines, this calcium carbonate combines with sulfuric acid, it forms what? H2CO3. It forms water plus carbon dioxide, and you get calcium sulfate. Now this calcium sulfate forms a layer. Okay, layer over calcium carbonate, right? And this layer does not allow acid to react. So it acts as a wall, or this acts as a barrier. So it is actually a wall which will not allow sulfuric acid to react. Likewise happens with lead carbonate. Hence you will find with calcium carbonate and lead carbonate the reaction is seen to stop. The reason is this formation or deposition of calcium sulfate or lead sulfate, right? And these two are water insoluble salts, so they deposit on the carbonates. Right. Next, if we take metal hydrogen carbonate. So metal hydrogen carbonate is, suppose we take hydrogen carbonate, HCO3. So metal hydrogen carbonate will be MHCO3. So when we take metal hydrogen carbonate, again what will happen? You have got HCO3, and from the acid you have got what? Hydrogen. So acid, hydrogen and HCO3 from salt will combine to form water and carbon dioxide, right? And you will again get metal and sulfate. Is this clear? So you will get metal sulfate. So similarly, if you take sodium hydrogen carbonate, you will get sodium sulfate, water, carbon dioxide. Likewise, magnesium carbonate will combine with sulfuric acid, dilute, and you will get magnesium sulfate, water, and carbon dioxide. Okay, now we move on to the metal sulfides. Okay, now metal sulfides are SO3 with 2 minus, SO3 2 minus. So what will happen? Like carbonate, sulfides also have SOO3. So this is what? Sulfur dioxide. This oxygen will be there left. This oxygen will combine with the hydrogen and will form what? Water. So the reaction is very, very simple. Okay, so now let me make it little clear so that when I'm explaining you are able to see. So the hydrogen from sulfuric acid and sulfide will form what? Water and sulfur dioxide, and you will get metal and sulfate. Okay, so similarly you will get magnesium sulfate, zinc sulfate, copper sulfate. Right, now if you take hydrogen sulfide, so like hydrogen carbonate, here also what is hydrogen sulfide? Let me explain it here. Right, so it is HSO3 minus 1. So this is what? H, right? SOO. So this is what? Sulfur dioxide. This is H, and O is what? OH, right? So this OH will combine with hydrogen of sulfuric acid and will form water and sulfur dioxide, right? Water and sulfur dioxide, and you are going to get metal and sulfate. So you will get here, you will get 2 molecules of sulfur dioxide, right? So what are you getting? You are getting with hydrogen sulfide, water, sulfur dioxide, and metal sulfate. Remember, in all these cases we have taken which acid? We have taken dilute acid. So these properties confirm the acidic nature of sulfuric acid. Thank you.